You passed your CCNA. You've memorized the flashcards, you know your routing protocols, and you understand the acronyms. But if you walk into a technical interview relying on that rote memory, you are going to struggle. Senior engineering managers sitting across from you do not care if you can recite trivia. They are actively testing how your brain works when a network breaks. We can visualize this gap by looking at how different answer styles impact your technical standing. A standard textbook definition hits a ceiling very quickly. To move toward that top right quadrant, you have to demonstrate that your knowledge is actually functional. In a live production environment, someone who only knows textbook theory without understanding practical application is a liability. Interviewers are specifically screening to ensure you can do the job, not just pass the test. To bridge that gap between the raw knowledge you studied and the clear communication a senior engineer expects, you need a specific mental model. We call it the DEU framework. The first step is definition. This is where you quickly prove your baseline academic understanding of the concept. Next is example. This is your evidence. Giving a concrete example proves you have actually seen this technology deployed in the real world. Look at this formula. The final step is use case. This is where you connect that technical concept directly to a business outcome or a specific troubleshooting scenario. Structuring your answers this way forces you to stop rambling. You bypass the filler and speak exactly the language the interviewer is waiting to hear. Let's apply this to the OSI model. The textbook definition states it's a 7-layer standard framework used to understand how data flows across a network. If you sit in an interview and simply list the layers from physical up to application, you prove absolutely nothing. Everyone who passes the exam can do that. This comparison matrix shows how to reframe the answer. For the use case, you explain that senior engineers rely on the OSI model strictly as a structured framework to isolate where a network failure is actually happening. For your example, you point out the stark difference between chasing a physical cable fault down at layer 1 versus tracking down a misconfigured IP routing issue up at layer 3. By treating the OSI model as a diagnostic map instead of a trivia question, you immediately signal your practical competence to the hiring manager. Moving to IP addressing. An IP address is unique, a logical identifier for a device so it can seamlessly communicate. Subnetting is the mathematical division of one large flat network into smaller, distinct subnets. This is our example, cleanly splitting a /24 network down the middle into two /25 networks. The use cases are efficiency, packing IPs tightly without wasting space, and segmentation, containing broadcast traffic. The trade-off? More complex routing and permanently burning network and broadcast addresses. Subnetting is a deliberate choice. You are sacrificing setup simplicity in exchange for essential efficiency and traffic control. At the transport layer, you face a fundamental conflict. You must decide if your network requires absolute perfection or pure speed. TCP is a connection-oriented protocol built entirely to guarantee reliable data delivery. Your example and use case for TCP are HTTP web traffic or FTP file transfers. In these scenarios, if a single packet drops, the entire file corrupts and fails. The trade-off is that TCP forces the network to verify every piece of data through constant acknowledgements and retransmissions. All of that checking introduces significant latency. UDP is the connectionless alternative. It fires data across the wire rapidly, with absolutely zero guarantee that it will actually arrive. Your example and use case for UDP are live video streams or VoIP calls. Speed is critical, and dropping a single frame of video is entirely acceptable to keep the stream moving. Choosing a transport protocol comes down to a harsh engineering evaluation. You have to know what your application can afford to lose, time or data. Now, let's look at how a specific protocol utilizes those layers. DNS is the system that translates human-readable domain names into machine-routable IP addresses. As this matrix shows, the use case for DNS relies heavily on UDP. DNS queries must execute with extreme speed and minimal overhead to keep web browsing highly responsive. Because DNS relies on UDP, we hit a clear trade-off. Packets can and will drop silently. If that happens, the application layer itself has to step in and trigger a retry. Your example here is mapping a specific domain to an IP address using an A record, or pointing domain traffic to a mail server using an MX record. DNS deliberately accepts the inherent unreliability of UDP because that is the only way to achieve the instantaneous scale that the modern internet demands. Protocols, layers, and subnets do not exist in a vacuum. They are highly specific tools engineered to solve concrete business problems. The difference between a junior candidate and one who receives an offer is often the ability to articulate the why behind the technology. Review this completed matrix. When you map every answer through definition, example, and use case, you prove that you understand how technology connects to the business. The specific hardware vendors and tech stacks you use will change constantly over your career, but a structured, outcome-based approach to troubleshooting will never become obsolete. Take a look at this flowchart. I want you to transition from listening to actively building your own muscle memory. This is your hot seat challenge. Practice question 1. Explain the exact mechanics of the TCP three-way handshake. Practice question 2. Detail the exact sequence of events if a DNS resolution fails. Practice question 3. Explain the fundamental difference between the network layer and the transport layer. Before your next technical interview, I want you to answer those 3 questions out loud. You must force yourself to use the strict definition, example, use case format to simulate real pressure. Passive reading builds your theoretical knowledge, but when you bridge your technical skills with this level of structured communication, you stop sounding like a student and start sounding like the engineer they want on their team.